All right, so we took some time to do some hard work to determine ways, formulas really, to ultimately find a shortcut through taking the derivative when you have a function which is itself a sum of two functions, or a function which is itself a difference of two functions. And those rules worked out very nicely. The shortcuts were very nice to say that the derivative of a sum of functions is the sum of the derivatives of those functions. You just simply take the derivative of each piece, add it together, and when you have two functions which, a function which is itself a difference of two functions, you just take the derivative of each piece and put a minus sign in between. That's very nice. So let's just see this in action so we can sort of familiarize ourselves with the process to remind ourselves that all of the evidence that we worked out previously, while important to being able to see that these things work, in practice really never has to come up again. We did the hard work technically so that now we can just apply the methods that we came up with. So here, y is square root x plus, I want this to be 1 over x. Square root x plus 1 over x. Imagine this is our function. We want to find dy over dx. Well, if you want to find dy over dx, you know that dy over dx is just a notation for the derivative. So all we're trying to do here is find the derivative. Well, what is our function? Our function is square root x plus 1 over x. Note, this takes the form of some function plus some other function. And you know how to take the derivative here, because when you take the derivative is just the derivative of the first plus the derivative of the second. So let's run through that computation. So if your original function is square root x plus 1 over x, the derivative is, well, take the derivative of the first bit. We've computed that already. That's 1 over 2 square root x. Put a plus sign in between. Why? Because there's a plus sign in between in the original, there's going to be a plus sign in between in the derivative, and then take the derivative of the last guy, 1 over x. That derivative is minus 1 over x squared. So I guess technically, rather than saying plus a minus, maybe it's better to just write that with a single minus, and we've got it. So the long story short is, we started with a function which was itself a sum of two functions. We took the derivative of the first bit, we took the derivative of the second bit, and we added them together. What about down here with this function? This function is two functions being subtracted. Well, two functions being subtracted sort of works the same way. If you have a function which is composed of two functions being subtracted, you take the derivative of the first, the derivative of the second, and you put a minus sign in between. So, to find the derivative here, to find f prime, take the derivative of the first. We know that to be minus 1 over x squared. Put a minus sign in between. Why? Because there's a minus sign in between in the original problem. And then take the derivative of x squared. The derivative of x squared is 2x. Problem solved. So what you can see here is the technical details at this stage are minimal. Because if we have these derivative sort of computations already done, if we know how to deal with a derivative, or rather a derivative when that function is a sum of two functions or a difference of two functions, well then we just have to apply that. So we've got a difference of two functions, we take the derivative of the first, the derivative of the second, put a minus sign in between, problem solved.